Why, hello there, lovely one. So we are going to look at measures of dispersion, and I've gathered all of these in the same list because they're quite strongly related to each other. Some of them are how we represent data, some of them are how we comment on data, and then some of them are the calculations that go with it. Now, range is the main measure of dispersion that you've done before, and of course, that is the difference between your maximum value and your minimum value. When you've subtracted them, you will get the range, and that tells you how the value is spread over those numbers. 5-number summary is actually one of my favorite things to do. It's quite satisfying. So the first thing we're going to do, though, is start with a set of data. So this example is taken from the Everything Maths textbook produced by Siavula. It's the Grade 10 Teacher's Guide. And it says a group of 15 learners count the number of sweets they each have, and this is the data they collect. Now, previously I've said the best thing to do with any questions that have sets of data is to arrange it in ascending order. And you'll see as I did this, I crossed off the numbers I'd put down, and then as the last check, I did count that I had exactly 15 numbers listed there. So let's start with looking at the range, because everything, well, all of those are interconnected. So I'm going to write down minimum, and I'm going to write down max down here. And there's a reason I'm leaving space, but let's just go with it for now. Our minimum value is 4 and our maximum is 14. So if we wanted to calculate range, it's going to be 4 minus 14, or sorry, 14 minus 4, which gives us 10. With a 5-number summary, it means that we need to have another 3 numbers between those. So right now I'm writing down Q1, Q2, and Q3. Those Q's stand for quartiles. So we've got quartile 1, which marks the last number in the first quartile. Quartile 2, which is also the median. So quartile 2 we find in the same way as we find the median, and then quartile 3 marks off the end of the third quarter, and then max marks off the end. So when I do this, I cross off once again to find the middle term, which is the median. And of course, the other way to determine the position of the median is to take the number of sets of data we have, add 1 and divide by 2, and that tells us it's in the 8th position, and you would count off 1, 2, 3, 4, 5, 6, 7, 8 to find that 8th position. Now to find your quartile 1, you're looking for the number or set of data that's directly between the minimum and the median, so that it divides this part in half, therefore showing 2 quarters. So I have crossed off, leaving out the 8, I've crossed off so that I get to the middle term of those, and that's going to be 6. So you can see the first quarter, including the 6, has 4 numbers. The second quarter, going up to our halfway mark, which is our median. Our second quarter, Q2, is marked by 8, which means our third quarter will end at 12. The way we can calculate the position is we add the numbers together, as you've seen before, but now for quartile 1, you're going to divide by 4 rather than by dividing by 2. And for the third quartile, if you wanted to work out the position, you would divide by 4 to change it into quarters, but then because you're looking for the third one, you'd multiply by 3, which would give you the 12th position, which coincidentally is also the number 12. So this is the 5-number summary. The types of questions you can be asked based on it, well, one of the main ones is something called an interquartile range. Interquartile means that we're looking at the quarters and we're saying what is the range between the third quarter and the first quarter. So we are taking 12, which is the value at Q3, and we're subtracting 6, which is the value at Q1, which gives us an interquartile range of 6 sweets. Another thing they can ask about are percentiles. Now, when they're talking about percentiles, they're talking about these quarters once again. So this first quarter we call the 25th percentile. Then we've got 50th percentile, so it goes all the way up to percent, 50% of the people. Then 75% would be the 75th percentile, and you get the idea. So when they're talking about that, that's how they're doing it. You're using your 5-number summary and saying that those are equal. I suppose I should erase this because it looks like a fraction. There we go. Box and whisker plots are a visual representation of the 5-number summary. So in order to do them, you first need to find the 5-number summary. Then you're going to draw a timeline, and let's just get that going over here, or not so much timeline, just a number line. And your numbers are going to be equally spaced. We're starting at 4, and we're going all the way to 14. So you'll see that once I've filled in all of the numbers that are represented with my 5-number summary, I've also put lines at each one of the quarters, and at the minimum, there's a minimum and the maximum. So the minimum was at 4, Q1 at 6, Q2 at 8, Q3 at 12, and Q4 at 14. This is called the box and whisker plot because of the way it looks. The box is formed in the middle by joining those lines over there, and then I'm sure you then realize that the whiskers are formed. Let's just move my ruler over there so it looks kind of like, whoopsie, trying to get this ruler straight. Anyway, it looks kind of like, well, box and whisker plot. Now I'm just talking about this quickly, and I'm going to highlight it just so that we can see what I'm talking about. We were talking about percentiles. This little red block indicates 25% of the people had between 6 and 8 sweets. Another 25% of the people had between 8 and 12 sweets. So it's showing us that there are the same number of people in this quarter as they are in that quarter. However, in this quarter, they had less sweets, if that makes sense. But anyway, there are also the same number of people gathered in that quarter as there are in this quarter. Your interquartile range is looking at the distance between 6 and 12. Now you are often asked, if not all the time, asked to comment on the skewness of this graph. You can see that this graph has a bigger space, or spread out more, on the right side. So we say that it is skewed to the right, and it is literally that easy. You would write down skewed to the right. You can also say that it is positively skewed because it's on the positive side. If this were longer, so let's just do a rough drawing over here. We had a box and whisker plot like that. If this side is longer, then obviously it's skewed to the left, or it's negatively skewed. Now, sometimes they'll ask you to comment on how it's skewed based on 2 sets of data or 2 sets of information. Anyway, they'll want you to compare the mean and the median. So if box and whisker plot are symmetrical, in other words, they look the same on both sides, the mean will have the same value or be very close to the same value as the median. If it is skewed to the right, it means that the median, is going to be smaller than the mean. So the mean will have a greater value. And if it is skewed to the left, you guessed it, the mean will have a smaller value than the median. And if you remember the mean, that's x bar on your calculator, and it's the average. There is actually a really, really good note on this from the Mind Action Series Grade 10 textbook, which I have now put up for you. And it shows how things are skewed. So when they're symmetrical, the mean equals the median, and there it is. There's the histogram. That's what it would look like if the box and whisker plot were done like that. We've spoken about a frequency polygon, and then this is something called the distribution curve. And then positively skewed, you can see that, and negatively skewed, and you can see that to the left. And I realize this is getting quite long, so I'm going to try and speed through the last bit I said we would do, which is outliers. Now, outliers are calculated using the interquartile range, which is why I've scrolled back up to here. Outliers are the things that don't fit in the set of data. So let's say in this particular list of numbers, there was one person who got 0 sweets. Now that person who had 0 sweets is very, very different from everyone else. So they would be considered an outlier. A more obvious example of an outlier was maybe someone who got 100 sweets. So over there. Now they definitely don't fit into that set of data. They're the only one who has 100 sweets. There is a mathematical way to calculate this. We're going to take the IQR and multiply it by 1.5. That will give us an answer of 9. So that is, well, so to find the outliers then, we've got to take the value of Q1 and we're going to subtract this 9. And anything that falls below that is going to be an outlier. We're also going to take the value of Q3 and we're going to add that 9 to it. So the value of Q1, if I scroll across quickly, is 6. So that's going to be 6 minus 9. And that means whoever got less than -3 sweets would be considered an outlier. In other words, someone that doesn't fit in with the set of data. And Q3 had a value of 12. So we add 9 to that and we're going to get an answer of 21. So anyone who had more than 21 sweets would also be considered an outlier. So you remember just now I said, what if there was someone who had 100 sweets? They would be considered the outlier. Well, well done for sticking with me for this long. We have covered everything I thought we would. Much love.